Hello everyone, welcome to the series where we are covering quantitative aptitude questions from UPSC CSAT previous year papers from 2016 to 2025. In the previous few sessions we covered questions on number system from 2016 to 2021, and in this session we will cover quantitative aptitude questions from UPSC CSAT paper 2022. So without any further ado, let's begin with the questions. Question number 1 is, which number among us 2 raised to power 40, 3 raised to power 21, 4 raised to power 18 and 8 raised to power 12 is the smallest? Okay. Now let's see. The given numbers are 2 raised to power 40, 3 raised to power 21 and 4 raised to power 18 and 8 raised to power 12. Now in these numbers we can write 4 raised to power 18 as 2 raised to power 2 into 18, and similarly 2 raised to power 3 into 12. Okay. So the final numbers become 2 raised to power 40, 3 raised to power 21 and it is 2 raised to power 36 and similarly 2 raised to power 36. Okay. Now this number and these both numbers are equal, and the first number 2 raised to power 40 is not the smallest number, but according to the question one number has to be the smallest number, so we are left with one option, that is 3 raised to power 21. So 3 raised to power 21 is the smallest number, right? So here our answer is B. Let's move to question number 2. The digits 1 to 9 are arranged in 3 rows in such a way that each row contains 3 digits, and the number formed in the second row is twice the number formed in the first row, and the number formed in the third row is thrice the number formed in the first row. Repetition of digits is not allowed. If only 3 of the 4 digits 2, 3, 7 and 9 are allowed to use in the first row, how many such combinations are possible to be arranged in 3 rows? Now in this question we need to find the number of combinations, such combinations which meet the following criteria. First is that the digits 1 to 9 are arranged in 3 rows. That means each row consists of 3 digits, right? And the digits allowed for the first row are digits allowed for the first row contains digits 2, 3, 7 or 9. Okay. Now number formed in the second row is twice the number in the first row, right? Similarly, number in the third row is thrice the number in the first row, right? And finally, none of the digits repeats repeat in any row, in any combination, in any combination. Okay, that means one combination has 9 digits and none of the digits repeats in that combination. Okay, now based on these conditions, only two combinations are possible. First is 273 and second is 327. Okay, now the number in the second row will be, since it is the twice the number in the first row, it will be 6, 4, 5, and here we have 819, right? Similarly, here we have, right? So only these two combinations are possible, and in these two combinations none of the digit is repeating, right? Rest all of the possibilities or numbers for the first row, okay, will not meet the all the conditions. Okay, because suppose we have a number 279, right? Then the digits will start repeating. Okay, let's see. For example, we have this number in the first row, then the second number, the number in the second row will be, okay, so digits started repeating, so all other combinations are invalid, so only two combinations are possible. So right answer is C here. Let's move to question number 3. Now question number 3 is, how many 3-digit natural numbers without repetition of digits are there such that each digit is odd and the number is divisible by 5? Now here we need to find all 3-digit natural numbers which consist of only odd digits and that number should be divisible by 5, right? Now since this number is divisible by 5, it must have 5 at units place, right? Now this number must be in the form of 1 to 5, right? We must have 5 at units place. Now we are left with only two positions and we have four digits, 1, 3, 7 and 9, right? Since none of the digit repeats in that number, so we are left with four digits and two positions. Now these two positions can be filled in how many ways? Right, it will be 4, 3, 2, 1, right, and it will be 12. So right answer is 12 here. Okay, now let's move to question number 4. Consider the question and two statements given below. Question is, if x is an integer, now we are given two statements here. X upon 3 is not an integer. Now according to statement 1, if x is any number and that is divisible by 3 gives a non-integer number, then x is an integer, right? Let's verify this statement is sufficient to answer the question or not. Okay, similarly we have to verify statement 2 whether it is sufficient to solve the to answer the question or not, right? Now first of all let's see statement 1. Now, according to statement, x upon 3 is not an integer, right? Suppose x is 5, which is an integer. Now, x upon 3, that is 5 upon 3, not an integer. Similarly, when x is equal to 1 by 2, now here x is equal to 5 is an integer. Here x is equal to 1 by 2, not an integer. Now x by 3 will be 1 by 6, not an integer, right? So we cannot say with certainty that x, when x divided by 3 gives a not an integer value, then x is an integer. Now let's see, according to statement 2, 3x is an integer, right? That means when we multiply any number by 3, and if it is an integer, then x is an integer, right? Now suppose x is equal to 1 by 3, then 3x is equal to 1 is an integer, right? But when x is equal to, say, 2, 3x will be 6. It is also an integer. So in this case also, we cannot say with the certainty that that x is an integer, because we have taken x as integer and x as non-integer, right? So we cannot solve this question even with the help of second statement. Similarly, we cannot solve this question by taking both statements together. So in this question, right answer is D. Both statements 1 and 2 are not sufficient to answer the question. Now let's see question number 5. Let A, B and C represent distinct non-zero digits, right? That means none of the digits repeats. Distinct non-zero digits. Suppose x is the sum of all possible 3-digit numbers A, B, C without repetition. Suppose we have digits A, B and C, then x is equal to sum of all possible combinations of A, B, C, right? For example, A, B, C, B, A, C, C, B, A, like this. Now statement 1 is the 4-digit least value of x is 1332, and statement 2 is the 3-digit greatest value of x is 888. Okay. Now in this question, let's see. So here we are given A, B, C as distinct non-zero digits, and we need to find the sum of all the combinations of A, B and C, and then we will verify if the least 4-digit sum of these numbers is 1332. Okay. Now sum of all numbers consisting of, say, digits A, B and C, where A, B and C are distinct non-zero digits, right? Then according to statement 1, 4 digit least value of x, 4 digit, sorry, okay, 4 digit least value of the sum is 1332, right? Now since we are asked to find least value of the sum of 3 digit number, right? Now the sum will be least when the digits are least, are smallest digits. Okay, suppose we have 1, 2 and 3, right? Now let's add all the numbers consisting of digits 1, 2, 3, and these numbers are 1, 2, 3. Okay, then 1, 3, 2. Okay, then 2, 3, 1, then 2, 1, 3. Similarly 3, 1, 2 and 3, 2, 1. Now if we add all these numbers, then the sum will be 2, 6, 8, 3, then again 3, 1, right? The sum will be 1332. That means statement 1 is true. Okay, correct. The least sum of the 4 digit least value of the sum of 3 digit numbers will be 1332. Now let's see the second statement. This statement cannot be true because the least sum is a 4 digit number. So this second statement automatically stands incorrect, right? So answer is 1 only. Now question number 6 is, there is a numeric lock which has a 3 digit pin. The pin contains digits 1 to 7. Next, there is no repetition of digits. The digits in the pin from left to right are in decreasing order. Any two digits in the pin differ by at least 2. Now, how many maximum attempts does one need to find out the pin with certainty? Now, the maximum number of attempts will be equal to the number of combination of 3 digits. Okay, which is to say that here in this question we need to find all the numbers consisting of 3 digits, right, based on the given criteria. Now the given conditions are: number 1, the number consists of 3 digits, right? And the digits are from 1 to 7, right? Second, repetition of digits not allowed, right? Third is the digits from left to right are in decreasing order. And finally, any two digits in the number, or you can say pin, that means pin, right, differs by at least 2, right? That means the difference between any two digits can be 2 or more than 2. Now, based on these criteria, we need to find how many such number exist, right? So let's take an example. The numbers can be in the form of 7, 5, 3. See here, 5 is less than 7, 3 is less than 5, and the difference between any two pair of digits is 2, here 2 or more than 2, right? So let us write other such combinations, right? Then we can have 7, 5, 2, right? We can have 7, 5, 1, right? Next we can have 7, 4, 2, 7, 4, 1, and 7, 3, 1. Similarly, we can also have 6, 4, 2. We can have 6, 4, 3. Okay. We can also have 6, 4, 1, right? And we can have 6, 3, 1. No, this combination is not possible. Here we have difference of 1 only. Okay. Now 6, 4, 1 possible, 6, 4, 2, 6, 3, 1, and 5, 3, 1. So how many number are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So right answer is C here. Now let's see question number 7. What is the smallest number greater than 1000 that when divided by any of the numbers 6, 9, 12, 15, 18 leaves a remainder of 3? Now to solve these types of question, we need to find the LCM of all the given numbers, right? Now let's see LCM of 6, 9, 12, 15, and 18 is 180. Okay. Now when we divide 1000 by 180, there will be a remainder of 100. Okay, so the smallest number greater than 1000, that will be completely divisible by 180 will be 1000 plus 80, 1080, but we need a remainder of 3, right? Then that number will be equal to 1080 plus 3 is equal to 1083. So right answer is C here. Let's move to question number 8. Now we are given some statements here. Based on these statements, okay, we need to find which of these statement is correct. Now consider the following statements in respect to natural numbers P and Q such that P is a prime number and Q is a composite number. Now statement 1 is PQ can be an odd number. Let's suppose P is a prime number. Let's say it is 3, okay, and Q is a composite number. Say it is 9. Now P into Q is 27, which is an odd number. So statement 1 is correct, right? Now let's see statement 2. Q is a composite number, and when Q is divided by primary number, then it gives a prime number. Suppose Q is equal to 6, which is a composite number, and P is equal to 3, which is a prime number. Now Q divided by P will give 6 divided by 3 is equal to 2, and 2 is a prime number, right? So statement 2 is also correct. And now statement 3 is P plus Q can be a prime number, prime number, right? Suppose P is equal to 2 and Q is equal to 9, right? Q is a composite number, P is a prime number. Now P plus Q is equal to 11, which is a prime number. So statement 3 is also correct. So right answer is D, 1, 2 and 3. Now question number 9 is 15 into 14 into 13, so and so on to as 3 into 2 into 1 is equal to 3 raised to power m into n. Where m and n are positive integers, then what is the maximum value of m? Here on the left hand side we have factorial of 15, right? Now we can solve this question by two methods. First is manual method, that is we can calculate the powers on the powers of 3 on the left hand side, okay. Now let's try to solve this question by manual method first. Now we can write 15 as 5 into 3, and then there will be a 12, and it will be 4 into 3. Then we will have 9, it will be 3 into 3. Now 6, we will 2 into 3. Then we will have 3, 3 into 1. Now how many powers of 3 are there on the left hand side, or you can say how many factors are there on the left hand side? 1, 2, 3, 4, 5 and 6. So right answer is B here, 6. Now we can also solve this question by other method, right? So here value of m will be, that is maximum value of m will be integer value of 15 divided by 3 raised to power 1 plus integer value of 15 divided by 3 raised to power 2 plus integer value of 15 divided by 3 raised to power 3 plus so on until integer value of 15 divided by 3 raised to power n is 0. Right? Now let's see, when 15 divided by 3 integer value plus integer value, when 15 divided by 9, and when 15 integer value when 15 divided by 27, right? Here it will be simply 5 plus when we divide 15 by 9 we get integer value 1, and here we get 0, so it will be 6, right? So again 6, right? So answer is B here, 6. Now let's see question number 10. If P be a 2-digit number and Q be a number consisting of same digits written in reverse order, if P into Q is equal to 2430, then what is the difference between P and Q? Right? Now here, suppose the given numbers are x, y and y x. Say P is equal to xy and Q is equal to yx. Right? Now, if we closely analyze the product of both numbers, that is P is equal to Q is equal to 2430, this implies that one of these numbers, that is either P or Q, has 5 at units place. Only then we can have 0 in the product of both these numbers. Okay, right? So the number can be, so the number can be x5 or Q as 5x, right? Now to have 0 in the final product, we must have x as an even integer. Okay, that means we can have x as 2, 4, 6 or 8, right? Now let's see when x is equal to 2. When x is equal to 2, the number will be 25, and the second number, that is p, will be 25 and q will be 52. If we multiply both these numbers, p into q, then it will be 1300. Now, but we need a product of 2430, so x cannot be equal to 2. Now let's see, when x is equal to 4, then the numbers will be 45 and q will be 54. Now if we multiply p into q, that will be 2430, right? And now we need to find the difference between the two numbers. Now q minus p will be 54 minus 45, and it will be 9. So answer is D here. Now let's move to question number 11. The sum of three consecutive integers is equal to their product. How many such possibilities are there? Right? Now suppose three consecutive integers are x minus 1, x, and x plus 1. Right? Now according to the question, their sum is equal to their product. Now x minus 1 plus x plus 1 is equal to x minus 1 into x plus 1. Okay, now minus 1 gets cancelled out with the 1. It will be 3x is equal to, it will be x square minus 1 into x, right? Now x gets cancelled out with x, and 3 is equal to x square minus 1. X square is equal to 4 and x is equal to 2 plus 2 minus 2 and 0, right? Now when x is equal to 2, right, then consecutive integers are 1, 2 and 3. Okay, when x is equal to minus 2, the numbers will be the integers will be minus 3, minus 2, minus 1, and when x is equal to 0, the number will be minus 1, 0 and 1. So there are three possibilities. Okay, so only three. Answer is C here. Now question number 12 is, what is the number of numbers of the form 0.xy where x and y are distinct non-zero digits? Okay, now the number is in the form of 0.xy. Okay, now we total digits are 9. Now we here we need distinct non-zero digits. Non-zero, that is, we cannot have zero. And the remaining digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we have two positions and 9 digits, right? So we can have how many possibilities? Suppose we select one digit for x, right? We have 9 for this first position, and then we will left with 8 digits here, or vice versa. If we have 9 and we have 9 choices for this y is this position, then we will be left with 8 positions for with 8 digits for this position. So overall total possibilities of possible combinations or possible numbers will be 72. So here right answer is A, right? So these were few questions from UPSC CSAT paper 2022. All these questions were on number system, right? So that's all for today. If you like the session, please do share, subscribe and support our channel. Thank you.